Alright, so today we're going to focus on Snell's law and the refractive index. And so we're going to explain how light bends when it passes from one medium to another and the principles that govern this behavior. Whether you're prepping for the MCAT or just looking to deepen your understanding, this video is for you. So refraction is the change in direction of light as it passes from one medium to another. This bending occurs because light travels at different speeds in different media. The degree of bending depends on the refractive indices of the two media and the angle at which the light enters the new medium. So this leads us to Snell's law. Snell's law describes how light bends when it passes between two media with different refractive indices. It is given by the equation n1 sine of theta 1 is equal to n2 sine of theta 2. Here, n1 and n2 are the refractive indices of the first and second media, respectively, and theta 1 and theta 2 are the angles of incidence and refraction measured from the normal. The refractive index of a medium is a measure of how much the speed of light is reduced inside the medium compared to a vacuum, and it is defined by the equation n is equal to c over v. Here, c is the speed of light in a vacuum, which is approximately 3 times 10 to the 8 meters per second. V is the speed of light in the medium. Snell's law is fundamental in various applications, including lenses, prisms, and optical fibers. These devices rely on precise control of light refraction to function effectively. For example, lenses use refraction to focus light and form images. Prisms disperse light into its component colors based on varying refractive indices for different wavelengths. Now, let's test your understanding with a few practice questions. These are the types of questions that you might encounter on the MCAT. And again, Snell's law is often used with lenses, so please make sure to reference the video on lenses when coming to Snell's law. Question 1. Light passes from air, which has a refractive index of 1, into water, which has a refractive index of 1.33, at an angle of incidence of 30 degrees. What is the angle of refraction in the water? So the correct answer is A, 22 degrees. Using Snell's law, we can find that it's 1 sine of 30 is equal to 1.33 sine of theta 2, and we're solving for theta 2. So the way to tackle this for the MCAT is to essentially know the signs and understand what sine of 30 equals, and that's about 0.5. So basically you're taking 0.5 and multiplying it by 1, so it's 0.5, which is equal to 1.33 sine of theta 2. So now we divide 1.33 to the other side, and we get 0.375 is equal to the sine of theta 2. So now we have to take the inverse of sine, and oftentimes on the MCAT you're not going to have to do too much. Generally you're solving for actually the refractive index of something, but the sine of theta, or the inverse sine, you can have general estimations, and there's different flashcards in the app for more information on those, which is equal to 22 degrees. Question 2. If the speed of light in a medium is 2.25 times 10 to the 8 meters per second, what is the refractive index of the medium? A, 1.33, B, 1.5, C, 1.75, and D, 2. So I'm going to let you pause for a moment, but this is a classic example of the MCAT having close enough answers to where all it takes is just one slight miscalculation in order to get the wrong one. So it's very important to ensure that you have all of your decimal places in the correct spot and that you're using correct scientific notation and doing correct dimensional analysis. And this one's relatively straightforward. It is just going to be the refractive index is equal to the speed of light, which we already have, which is 3 times 10 to the 8th meters per second, over V, which is the speed of light in the current medium. And so that's over 2.25. So we take 3 basically divided by 2.25, and we get 1.33. And you'll know, just looking at the dimensional analysis, we're effectively canceling all of the units because the refractive index has no units. So that's how you know that you can eliminate certain ones on the MCAT if they provide the index in units. Question 3. Which of the following statements correctly describes the relationship between the angles of incidence and refraction when light passes from a medium with a lower refractive index to one with a higher refractive index? So the correct answer is A. The angle of incidence is greater than the angle of refraction. When light enters a medium with a higher refractive index, it slows down and bends towards the normal, resulting in a smaller angle of refraction. So these questions help to reinforce the concept of Snell's law and the refractive index. Understanding these principles is crucial for tackling MCAT questions related to optics. So to excel on the MCAT, it's crucial to master the following key points. One is Snell's law, understanding that the refractive index and the sine of theta of one medium is equal to the refractive index multiplied by the sine of theta 2 of another medium. The refractive index is the ratio of the speed of light in a vacuum to the speed of light in a medium. Third point is that light bends toward the normal when entering a medium with a higher refractive index and away from the normal when entering a medium with a lower refractive index. In summary, understanding refraction, Snell's law, and the refractive index is essential for mastering optics concepts on the MCAT. By grasping these principles, you'll be well prepared for the exam and future studies. If you found this video helpful, don't forget to like, comment, and subscribe to our channel for more MCAT prep content. Your support helps us continue to create informative videos to aid in your study journey. And if you're in the app, please make sure to leave a comment if you want more topics or if you have any questions. Thank you very much.